Alright, here we are on part 2. So let's see how that goes. We have this question to answer. Trying to fit it in my screen. Alright. Glare, glare, glare. Alright. Did you need to justify, I think I mentioned the answer to this question in the middle of the work. Let's see if you can answer it though. Apart from that, did you need to justify to know that the population distribution of egg weights was normal to complete part A or part B above? So the two that we just worked through. All right, and the answer to that is, you can pause it if you want to think about it. So another pause point. But the answer is yes, both part A required a normal distribution. There's no other way we could find any probability unless we do like a binomial or geometric function. And the only way we can use chart A is where the probabilities lie for us to gather, unless it is a normal distribution. So we did need to justify, and in part A it was told to us that the eggs were normal. Part A, where does it say that? Right there. It says egg weight is normal, so we didn't have to mess with it. But we did have to have that requirement met before we could do that. Part B, also we used chart A, did we not? So I had to justify that, and I did mention whenever we have a probability distribution that is normal, X bar is also normal, so we do not have to run a test. So that's how that works. I put it in words here. You can look at that while I look for problem number 12. All right, so problem number 12. I'm sure you don't have that one, so you can write it down. And here's the setup. Let me get some of these words out of the way, the clutter. All right. A radio station says that 20% of phone-in listeners are male. So they add another male host and then recorded the gender of 200 phone-ins, viewing these 200 as a simple random sample from the population. But really when they phone in, it's not. But they decided to go ahead and calculate this as if they were. So it's their choice. So here's the question. Assume adding the co-host has no effect. So that would mean up here that we would still have 20% of the phone-in listeners being male. So assume that adding the co-host, the male co-host, has no effect. If p hat is the proportion of call-ins that are male, what are the mean and standard deviation of p hat? All right, I want to start my timer again. Oh, great. Nice second. There it goes. All right, so if p hat is the proportion of call-ins that are male, what are the mean and standard deviation of p hat? All right. So in order to answer that question, let's pause and think about it, work it out, and come right back from our pause point. In order to do this one, you're asked to find the mean. So the mean of p hat is the mean of the population, 0.20. That's always one that we can grab. And the standard deviation of p hat is possible to calculate with a formula if it passes the 10% rule. So we're going to check, is the population of males in a listening audience greater than 10n? Well, they took a sample of 200, so we're going to assume, sorry out there, those naysayers out there, we're going to assume there are more than 2,000 listeners. So we're saying over 2,000 is greater than or equal to 10 times 200. So it checks. All right. So I'm assuming n is greater than 2,000. All right. So here we have the formula for the standard deviation of p hat. It's p square root of p 1 minus p over n. It's a little a little more involved than the standard deviation of x bar. Remember, x bar was just the old standard deviation divided by the square root of n. Quite different. So here we plug in 0.2, 0.8, and over 200, and we get a standard deviation for p hat as requested, 0.028. All right, did you get that? Let's go to part B. All right, what assumption was made to find the standard deviation in part A? Well, we already talked about that in detail. So we assumed that there was more than 2,000 listeners in the radio audience. So, all right, so let's go with that. Now we're going to go to the third question on that. And usually that's where we have to go to chart A if we can. So let's see what shakes out. 50 out of 200 callers were male. Does this provide sufficient evidence to suggest the proportion of male callers has increased from 20%? So we're going to need calculations to verify that. Definitely a pause point. Note that we're working with proportions, so we should have decimal numbers running around. All right, pause point. In order to do part C, I recognize that I made a proportion out of 50 over 200. 50 out of 200 is 25%, or 0.25. So I want to find out, in order to answer this, what's the probability that this has made a difference? So we're looking at, then I'll answer whether or not I think that there's evidence to support that the proportion of male callers has increased. And so we're wondering if this 20% idea holds true now. So with this data from this sample, what do you think? So we're going to look at the probability that the proportion would be greater than or equal to 0.25. And if it's a very slim probability that that happens, then I will assume that this number probably is no longer 20%. Now that they added that male co-host, this has probably changed for more. It's probably increased. So let's see what the probabilities yield. So the probability that p hat is greater than or equal to 0.25 is what I'm looking for. I'm going to need the mean, which is the regular proportion from the problem, the mean of p hat, and I'm going to need the standard deviation of p hat. And so I look at that. Using that formula, I got 0.028. From that, I will establish a z-score. You notice these problems are kind of repetitious. And so we take the 0.25. Notice it's a greater than or equal to, so that means in the end I'll have to subtract whatever's from chart A from 1, because our chart gives us less than. So I get the z-score from chart A, I get that value, and I subtract it from 1, and I got 0.0367. 3% is fairly low. I know you don't like these words, Caleb, but we're going to say 3% is pretty rare. So it indicates, because it's such a low probability, that 20% claim is no longer true, but has increased. All right, there you have it. Like it or not? All right, let's do the last one. All right, again, I realize you don't have these in your hand, but you are going to write them down and study them. The annual cost of textbooks is skewed to the left. Here are some statistics about that distribution. The minimum is 80. The quartile one is 215. The median is 335. Quartile 3 is 380, and the max is 440. So we're going to take 50 random samples. We're going to take 50 random samples, and each one has the size of 32. And they are selected, wait a minute. Yeah, let me read that better. 50 random samples of size 32 are selected, and the interquartile range for each is shown below. All right, I'm going to have to get that picture for you. So let me see if I can grab it quickly, and you can be writing that problem down. This is our pause point. I forgot the graph of it. Papers, papers, papers. Do you sometimes suffer from a paper blob? I do. Finally, I found it. Paper blob. Okay. I don't think you can really copy this part of the problem down, because how are you going to copy this graph? Sorry. Using up all our video time. Okay. Here is the graph of the interquartile range. See if I'm trying to get it to show up nicely. Fair. A little shaded there. If I get some better lighting. I think that's worse. So like blue. Alright. Here's the interquartile range. So, and here is the questions. So I'll keep it in line here. Well, I'll come back to it anyhow. I want you to explain what the dot at 240 represents. Yeah, this lighting's worse. Hold on. Alrighty. Goodness, it's gotten really dark in this room. Alright. Explain what the dot at 240 represents. So let's go over here and find what they're talking about. So the dot at 240 is right there. So pause point, and you can answer that question and come back. All right, what that dot represents is that there were, as we stated, a number of random samples taken. And turns out there were 50 random samples. One of those samples had an interquartile range of 240. And it was plotted right there. So that's what that dot means. It's the interquartile range of one sample. And here's the ranges of all of the other ones. All right, so more importantly, the question next is the sample IQR an unbiased estimator of the population IQR? So is the sample IQR unbiased? All right, we like that question, don't we? All right, the answer to that question is coming up. So pause point, think about it. Papers, 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 papers. All right, I'm back, sort of. In order to answer that question, I kind of need to figure out what the center of that graph is. So I noticed that if I was to draw a shape around it, it's definitely skewed, and it's skewed, we're going to be skiing to the right, skewed right. So if you recall, if we had a normal curve, the mean would be where the highest hump is. But when it's skewed this way, it pulls the tail. The mean goes this way. So I would say that if this was a normal curve, the hump would be right here. But because it's skewed to the right, it's going to be pulled down somewhere. So I don't know exactly where, but say it's pulled down to here. That's a fair guess of the center. So we're always looking for the mean of our sampling distribution. So it looks like, if this is 160, 170, maybe it's somewhere around 160, 165. So that is the mean of my samples of IQRs. Now, if that mean is equal or very close to the mean of the actual problem, or the given, or the IQR, let's say that again. So I'm checking the center of the graph, and it looks